Okay, for Mr. Berry geometry for the parallel and perpendicular assignment, this is the 15th, and I think that is due tomorrow. If I check really quickly, yeah. So this is the assignment that's due on the 16th. Okay, and hopefully this will give you a little bit of help along the way. For these exercises, are lines L1 and L2 parallel? Well, since you're looking at a graph, you don't have to plug these numbers into the slope formula, which is m equals y2 minus y1 over x2 minus x1. We could do that, but you might as well just figure out the slope. So I did that here. So the line that contains 0, 3, and 4, 1, if you notice, it goes down 2 over 4, or negative 1/2, okay? And remember, parallel slopes need to be the same. The line that contains negative 6, 1, and 0, negative 2, it goes down 3 over 6. What am I talking about? It goes down 3 over 6 to get to the next point. And that could be simplified down to negative 1/2. So they're both negative 1/2 slope, same slope, yes, parallel. Take a look at number 9. If you look at those 2 points that I'm pointing out right now, it goes up 6 over 4 or 3 over 2. And then these 2 points on the other line, that means it goes up 6 over 3 or just 2. So they are different, so that means they are not parallel. So different slopes, they're not parallel. Okay, so number 11, let's take a look at 11. So try the even ones on your own, do the same thing. Number 11, what we are to do is to write the equation of a line parallel to the given line that contains C. So here's the point, and here's this equation. We want to have an equation that is parallel to this that contains these points. So this is my slope. So basically, I just take that point and the slope, and I use point slope form. And I plug in the point, negative 2, and I plug in my y1, my x1. This is my x, this is my y. These are my sub 1, sub 1, okay? So this is my x, this is my y, and I plug them in where you see them, and I work out the equation to where it becomes into slope-intercept form. This is the equation of a line that is parallel to this line and contains these points. Do the same thing for number 13. I figure out that the number 13, the slope has to be 1/2 because this line slope is 1/2. And this point right here is going to be plugged into my x1 and my y1. Once again, I'm using the point slope form. Plug in the slope, just work the problem out. And this is the equation of the line that is parallel to this equation of this line, but contains these 2 points, okay? Because those 2 points belong in here. All right, so try 12 and 13, or 12 and 14. 12 may be a little tricky if you're not sure about, what is that? No, it just looks a little bit different. Do the same thing, it just looks a little different. Okay, so for 15, these are going to be perpendicular, not parallel anymore. So you're going to tell whether these are perpendicular. So once again, I'm just going to use points on the line and figure out the slope. And if it's, remember, if it's the opposite inverse, they're going to be perpendicular. So if I take a look at the line that has O, negative 2, 0, negative 2, and 4, negative 4, that is going to be a slope of negative 1/2. And then the points, these points on that other line the slope is 6 over 3, which is 2. This is the opposite inverse, okay? It's the inverse. It's actually, 2 over 1. You could think of it that way. And so it's the fraction flipped. And it's opposite. It's not negative, it's positive. So these are perpendicular. If you take a look at 17, I take those points, and I figure out that this line has a slope of -1. This line has a slope of 4/5. It's not opposite inverse, so it's not perpendicular. Take a look at 19. We're going to do the same thing that we did with parallel, but we want the opposite inverse. So the opposite inverse of 2/3 is 3 over 2 and negative. So -3 over 2, and then we want to contain these 2 points. I use the point slope form again. I plug in my slope. I plug in my x1, my y1, and I work it out. What's your x1 and y1 again? This is your x1, this is your y1. Take a look at 21. The slope would have to be 1/2. It would have to be positive, and it would have to be the inverse. Here's my x1, here's my y1. Okay, I plug those into that point slope form. Work the problem out, and that should be the equation. For 22, it's not that difficult. All you have to do is write this equation with a different slope. This is a -3/4. So you just have to rewrite this with a opposite inverse slope, and you'll find the equation, because it's going to go through the origin 0, 0. So it's going to be y equals 4 over 3x. And you're good. Okay, for 23 through 26, determine whether the lines are parallel and explain. Well, let's take a look at 23. I had to manipulate the second problem in order to get y by itself. You got to write it in slope-intercept form. I look at the slopes. Slopes are right here, -1, -1. They're parallel, they're the same. Take a look at 25. I had to manipulate these so that I can get y all by itself. When I do that, when I work this problem out, we have different slopes, so they're not parallel. And you're doing the same thing for 36 through 38, and I did 36, but your perpendicular, they have to be the opposite inverse, okay? So your reasoning would be, it's the same. Your reasoning for this not parallel, they're not the same slope. This one, it is perpendicular, because once you get y by itself, you have an opposite inverse. It's going to be perpendicular. And the opposite inverse, no, it's not opposite inverse. It's almost opposite, but no, not. I mean, it is opposite, but it's almost the inverse, but this is a 4 and that's a 2, so it's not perpendicular. Okay, hopefully this helps. And, and for 37, this is a perfectly horizontal line where it doesn't matter what x equals, your y is going to be 3. So in other words, it's going to be like this. 1, 2, 3. This is that line right there. Y equals 3. This is -2, so I go back 1, 2. This is a vertical line, so x equals -2. So obviously, yes, these are going to be perpendicular to one another, and your reasoning, because that's perfectly horizontal, that's perfectly vertical, so you're good to go. Hopefully this helps.